Well, good morning. We're going to start today with a quick review of yesterday's topic, finding standard deviation, utilizing the Google Sheet. We're going to do example number 5 here, which was a specific technology example in the textbook. It gives us a sample of office rental rates, dollars per square foot, for Miami's central business districts, shown in the table on the left. So I've already taken that table and transferred it into this Google Doc, which is titled 2.4 examples, and it's down at the bottom here as example number 5, and we can see that we've already got this data all put in here into list 1. So the first thing we are going to want to calculate here is we're going to want to calculate the mean of this data set. So I'm going to come all the way down here to the bottom. I'll type in the word mean, and say equals average, and we'll go ahead and highlight our data, and we'll find the mean of this data set. There we go. 33.74. We'll double check that, go back, take a look and see what they find. 33.73. We've got the same mean that they've found. It's important to note that this is a sample. We can right now go ahead in here, equals standard deviation, and highlight that data. We'll get the correct answer immediately because it is a sample. If it had been a population, then we have to go through the long way with all the steps. We'll do this really quick and get 5.08, which we will see is the same answer they got for their standard deviation here in the textbook. We'll just really quick go through the steps of doing this. Now that we have this 33.74, and that's what I'm going to utilize, here we're going to have to do x minus the mean. So we'll type in here equals this value minus 33.74. And keep in mind, anytime you're using a rounded number, there is a possibility that at the end your answer is going to differ a little bit than when you use the shortcut steps. We'll go ahead and drag that all the way down. Good. Next, we're going to come over here and we're going to do x minus the mean. That same number we just calculated, and we want to square that number. So we'll put in here equals this number we just calculated, x minus the mean, squared. Drag and drop that all the way down to the bottom. We've got that calculated. So the next thing we're going to want to do is find the sum of that. Type it right in here. Sum equals the sum of the information above it. We're going to go ahead and highlight that. We can see that's an important row. Okay. Now if we take that, actually we're going to go down here where we have all these other ones, might as well. Variance. And that is going to be equal to that number divided by how many data values we had, which in this case, because it's a sample, we're going to actually divide by one less than that. So we've got 1, 2, well, let's go back and just see. Right. Sample size, we've got 24 data values here. So since we're dividing by n minus 1 because we're using a sample, can we do this? Here. Well, doesn't matter. N minus 1, we're going to divide by 23. And we get this number. That's our popular sample variance. And now since we want the standard deviation, we're going to take the equals square root of that answer. We'll see how close we get. 5.8433, 1857 as opposed to 1839. Really, really, really close. So that small rounding we did on our mean really had almost no effect on our final answer. So there you go, how to find the standard deviation, again, using Google Sheets. Not difficult. You can use the shortcut as long as you know that it is a sample. If it is a population, you need to go through all of the steps. We don't have a shortcut for population standard deviation. So always when you're given a data set, think to yourself, does this data set represent all of my values or only part of the population? I'm going to move on now to example number 10, and this is a more difficult topic, only in that it has more steps. So examples 9 and 10 talk about finding standard deviation of grouped data. And we did the same thing with mean in section 2.3. First, we learned how to calculate mean of a data set. Then we learned how to calculate the mean of a frequency distribution. Same topic here. It involves considerable more steps. Example 9 is more of what we would call a discrete probability distribution, in that it has individual whole numbers for your classes. And you can then you don't have to find the midpoints. But for right now, since we're dealing more with frequency distributions, we're going to jump up here to example number 10. Example number 10 talks about how much people spend traveling. It's broken everything down into classes, 0 to 99, 100 to 199, and so on. The last class is a little different than what we're used to. It's 500 plus, everything above 500. But they do identify a midpoint for us in that case and tell us to use 599.5. So I already dropped this information for classes, midpoints, and frequencies into Google Sheets. The step we need to do now is we need to go through our process to calculate a mean. Remember that if we're going to calculate a mean in Google Sheets for a frequency distribution, our first step is to take our x values times our frequencies, and in this case, x values are the midpoints. We don't know all the data values. We're assuming that every value in 0 to 99 are all 49.5s, and there are 380 of those. So we've got some pretty big numbers in this example. It's one of the reasons why knowing how to use a technology tool for these calculations is important, because sometimes you're dealing with a large sample size. So we've multiplied those two cells together. I'm going to drag and drop that to the bottom, and it has done all the multiplications for us. Right now we're going to come down here, and we're going to find the sums. And equals sum of this information. Important for us, so that's 1,000. It's important for us to recognize that is n. That is our sample size. Also going to find the sum here. They suggested the equation for us. Very good. So I'm going to go ahead and highlight these three in the color so that we know that those are not part of our data calculations. Those are actually our sums. Okay, we need to calculate the mean. Right? And that mean is going to equal this number divided by this number. We've got a mean of 701.86. Something here is not quite right because our mean is not matching up with their mean. So let's take a look at our calculations here quickly. That number here divided by 1,000. They've got a different number than we got. Sum of x times f. 5 times 70. E2 through E7. Let's see. Oh, there's our error. Ready? See what I did? I typed in C2 times 380, and so it has kept that 380 through all of these. Good thing we double checked. So we're going to change that formula to equals this cell times this cell. And now we're going to drag and drop. And when we do this, Sheets should automatically adjust every calculation that we did. And it did. So now we've got 192,000 as our sum, mean of 192. Highlight those so we know that those are important. Let's go with a nice light red. There we go. We know those numbers are important. Next column, following through our standard deviation calculations, we need to do our x values minus the mean. So we will type it right in here, x minus the mean, and we will do equals minus 192. And we've got that column. Next, we're going to need to square that number. Now, this next column is where we are a little bit different on a frequency distribution than we are when we do the calculations for a regular standard deviation. The next column in this list is x minus the mean squared times f. And the reason we have that is that these are the deviations. This is how one data point in this class, 49.5, we know how the deviation for that single data point is negative 142.5. But that data point occurs 380 times. So we need to multiply, now that we've found that, and now that we've squared that number, we've got to remember that this occurs 380 times. This value occurs 230 times, and so on down the list. So now we have another column. We take that x minus the mean, the deviation value, that we have squared. We need to multiply that times our frequency. So we need to take this number here and multiply it by our frequency number. Now what we're going to do, again, we're finding sums here. We'll highlight this in green. We'll keep all the sums the same color. Equals the sum of this row. Sorry, this column. We get that number. We're going to come down here. We're going to find variance. We're going to find that by taking this number that we just found, and we're going to divide that by 999. Why 999? Because this is a sample. And when we divide it in a sample to find variance and standard deviation, we divide by n, our sample size, minus 1. And we're going to find standard deviation is going to equal the square root of that number. Let's hope we're correct. There we go. Sample standard deviation, they got 160.3. We've got 160.3. Let's try. We know that we could have back here done equals average, weighted average. We could have highlighted these numbers, comma, and these numbers. So we get the same answer. We do. So we could have done average weighted. Let's try our standard deviation check. So let's go ahead and here equals standard deviation. Don't know that we can do a weighted standard deviation. Yeah, see, that did not calculate properly. So it doesn't look like we can use our standard deviation shortcut for this. I'll look into it more and see if we could find something else out. So there we go. There's an example of how to do a frequency distribution and calculate its standard deviation. So I'm going to highlight these in a color so we can see them and know that they're important numbers. The only other topic in this section that you're going to need to take a look at today on your own is the topic of what we call the empirical rule for a bell-shaped distribution. A population that is, and an awful lot of populations that we study are what we call bell-shaped distributions. And a bell-shaped distribution has certain qualities. The mean is directly in the middle, and it's got this curve that reminds us of a bell shape. It's symmetric. It never crosses the x-axis, and we'll learn an awful lot about this in Chapter 5. And we see this symmetry here. I just said it was symmetric. For every value that's above the mean, there should be a value that's equally below the mean. Directly down the middle of our bell-shaped distribution is our mean. And one of the things we know about the bell-shaped distribution is that certain percentages are constant. And that is, if we look within one standard deviation above and below the mean, and that's why we're representing this here as x bar for the mean, and here we have x bar plus s, sample standard deviation, x bar plus 2s, meaning we're 2 standard deviations larger than the mean, and plus 3s, minus s, minus 1 standard deviation, minus 2 standard deviations, minus 3 standard deviations from the mean. 68% of a population will fall within 1 standard deviation below and 1 standard deviation above the mean. As we move further out, 2 standard deviations in each direction, we're now at 95% of the population falls within those values. And finally, within 3 standard deviations, 99.7% of your population. Now, there's another 0.3% that's left over that we haven't talked about. Remember that your distribution is symmetric. So 0.3, if we split that in half evenly, there's 0.15% left over up here and 0.15% that still exists outside 3 standard deviations below. Okay, empirical rules explained here. Make sure you take notes. If we were doing an in-class quiz, the first question on the quiz would be to draw and fully label this diagram. You do need to know this diagram. It is important in statistics. Look at this example. Survey conducted by National Health Statistics. Women aged 20 to 29, they have a mean height of 64 inches and a standard deviation of 2.75. What I would do is exactly what they did right down here in this picture. I would draw a bell curve. I would put my mean of 64 in the middle, and I would start counting off on the x-axis, adding 2.75 to get the next value. Add 2.75, a standard deviation, to get the next value. Add a 2.75. Get these values, mark them on your x-axis. Go the other direction. 64 minus 2.75. Minus 2.75, minus 2.75. Set this picture up, draw a bell curve, and put your values for your situation on your x-axis. That is going to make it much easier for you to answer the questions that can then be asked. They asked the question, estimate the percent of women who fall between 64 inches and 69.5. Now, again, 68% within plus and minus 1 standard deviation, symmetry says that divides up evenly. So each half of that is 34. Then we add some to it. So we add another 13.5 on each side. We add another 2.35% on each side. So when they ask this question and they say, what percent of women are between 64 and 69.5, you can go to the bell curve that you drew. You can start at 64, go to 69.5, and you can shade that area in and say, okay, I've got 34% in this area, I've got an additional 13.5% here. I add those two together, I get 47.5%. Okay? The try it yourself problem, the next question. Estimate the percent of heights that are between 61.25 and 64. Well, since you have your drawing already done, look at 61.5. Look at 64. What space is in between? The answer to that's going to be 34%. This section of the bell curve right here represents 34% of your population. So I'm going to assign some examples or some questions today that utilize that. I'll scroll ahead here to the questions section. Oh, we already passed some of it. So we did a lot of problems yesterday. I'm going to pick and choose some other ones, some review problems from yesterday, as well as some of the new stuff we just talked about. So that's it for this morning. And check out the Friday overview as soon as I post it in about 5 minutes. And thanks for listening, and good luck.